All right, ladies and gentlemen, we're going to talk about today is the different types of quadrilaterals and how do we know when we have a rectangle, a rhombus, or a square. What should we be able to see in them and what properties do they have? Okay, so let's start with the note here off to the right. And this is true for every quadrilateral. Rectangle, rhombus, square, parallelogram. Every quadrilateral has this property, okay? And it says, for every quadrilateral, the sum of their four interior angles is always equal to 360 degrees. Okay, so that's true no matter what quadrilateral that you have. So now let's take a look at this Venn diagram that we have here. If you're not familiar with the Venn diagram, this is what one looks like as it pertains to quadrilaterals. And the rule is pretty simple. If one type of quadrilateral, let's take a rhombus for example, has certain properties, because the rhombus is inside the circle of the parallelogram in this diagram, then all the properties of a parallelogram will be the properties of a rhombus, okay? And so on. For example, since the square is in the circle of a rectangle, then all the properties of a rectangle are true for the square, okay? And that's what this rule is trying to explain here. All right? So let's fill this in. A rectangle also has the properties of a parallelogram, and that's because, if you notice, the rectangle is inside the circle of the parallelogram. So the rectangle shares the property of the parallelogram, and it also shares the property of a quadrilateral, because all of these shapes here are inside the box of the quadrilateral. A square also has the properties of, so we look at the square is in the rhombus, it's also in the rectangle, it's in the parallelogram, and it's even in the quadrilateral. So it has all the properties of all quadrilaterals. So we'll write those down. Okay, so we're going to use the Venn diagram here to answer all the questions in F. Okay? On Google Classroom, go ahead and put your answers on the comments for these notes. So a square is blank, always, sometimes, or never a rectangle. So if you look, is a square part of the rectangle circle? The answer is yes. Therefore, the square is always a rectangle. Now we look at the next question. A rectangle is always, sometimes, or never a square. So let's look at our Venn diagram. So is a rectangle always a square? If you notice, there's part of the rectangle area that does not fit in the square. So there's some rectangles that are not squares. So it's not always. Is it never a square? If you notice, the circle of the rectangle is part of the circle of the square. So it's sometimes a square. Okay. Is a rectangle blank a parallelogram? The answer to that is a rectangle is in the circle of a parallelogram, so it's always. Is a parallelogram is blank a rhombus? And that answer is sometimes. And last but not least, a rectangle is a rhombus. Is always, sometimes, or never. So let's look for the rectangle. Is any part of the circle of the rectangle part of the circle of the rhombus? And the answer is sometimes, and that's when it's a square. The answer is sometimes. All right. Okay, let's go ahead and talk about a rectangle. So the definition of a rectangle is when you have a quadrilateral with 4 right angles. Okay, so that means all these angles here are right angles or 90 degrees. So remember, the box means 90 degrees. As a reminder, these statements here, they have a special symbol. This symbol here is perpendicular. The definition of perpendicular is when you have 2 lines that cross at 90 degrees, or in other words, at a right angle. So the way I would read this is that the line segment PQ is perpendicular to the line segment QR. So if you look, if I highlight these guys, PQ and QR, they cross at 90 degrees. And so do the other set of sides. And that's the definition of a rectangle. Also, when we need to name a rectangle, we name a rectangle by using the 4 letters, just like a parallelogram, P, Q, R, S. And we put the name of the shape. So we're dealing with the rectangle, and we put our 4 letters that we have, and you go in consecutive order, so around the shape. And it doesn't really matter which way you go or what letter you start with, as long as you go around the shape when you name it. Okay? So, because, if you remember the Venn diagram, a rectangle is a parallelogram. Because of this, because a rectangle is a parallelogram, then all the properties of a parallelogram are the same properties of a rectangle, because they are essentially the same shape. To add to that, because it's a rectangle, it has an additional property that we're going to talk about here. So a parallelogram is a rectangle if and only if its diagonals are congruent, which means they will have the same length. So in other words, CA has the congruent measure or the same measure as DB. Okay, so how do I use this? Let's do an example. So if you look, we know that this is also already a rectangle. So we want to figure out what X is. So given this information, we know that the segment from AC is 12. So this line in purple is 12. So all the way across from here to here is 12. We also know, because this is a rectangle, we know that B to D, let's put this in blue. From B to D, that is going to be the same as A to C. These 2 lines will be equal. And we know from B to D, the length is going to be 2x minus 4 and x plus 6. So let's write that down. So we know from B all the way to D, this is going to equal 2x minus 4, as well as we have to add in x plus 6 because we want the entire line segment. Okay? Because this is a rectangle, we now know we can put this information, because this is BD, we can set it equal to the purple line segment. And we know the purple line segment AC is equal to 12. Okay, and this is by the property of the diagonals have to be congruent. They have to be the same measure. Now this just turns into an algebra 1 problem, and we solve it out. So 2x plus x, that's 3x. Negative 4 plus 6, that's positive 2, all equal to 12. Subtract 2. 3x equals 10. So divide by 3. And x is going to equal 10/3. This is in fraction form, or in decimal form, x is going to equal 3.33. Okay, so we just used diagonals congruence of a rectangle. So now let's talk about a rhombus, and we're going to add two new properties. Okay, so a rhombus is a quadrilateral with four congruent sides. So what that means is PM, QP, QL, LM, these guys have all the same measure. So all sides are equal in measure. So we'll write that down. PQ, QL, LM, and MP. If you know one of these sides, because this is a rhombus, you know them all. So what are the properties? If you notice the Venn diagram that we've been dealing with, a rhombus has a property of a parallelogram. Okay? Since a rhombus is essentially a parallelogram, a rhombus is going to have all the properties of a parallelogram, plus we are going to add two more. So let's talk about the two new properties. So the new property is when you have a rhombus, then the diagonals are perpendicular to each other. Okay? So what that means is that these diagonals they will cross each other at 90 degrees. So that's what this box means. So as we mentioned before, perpendicular means creating a 90-degree angle. So these two lines cross at 90 degrees. I can now say this is 90-degree angle. All these four angles in here are 90-degree angles. Okay? So that's when you have a rhombus. The second property is those same diagonals will bisect opposite angles. Okay, so let's look at this. Let's color code this again. So let's talk about BD first. So the diagonal BD, what it will do is take angle D. So angle D used to be this big angle here. What the diagonal does, it says, I now cut angle D into smaller angles. But these two small angles are congruent. They're equal to each other. So angle D is now split into two equal angles. Same for angle B. Angle B was this big angle here, but because it's a rhombus, angle B is split into two equal angles. Same thing happens for this diagonal. because this is a rhombus, angle A is now split into two equal angles, and so is angle C. It's split into two equal angles. All right, so how do we use this? Let's go ahead and do this example. Okay, so in this example, our job is to figure out every blank angle measure. So I color coded them so they're easier to see, but we got to fill in the measurement for each of these green spots, these green angles. And we're going to use all the properties we can. The first one I see, because this is a rhombus, I know that these diagonals will cross each other at 90 degrees. That's this property here. So that means if they cross each other at 90 degrees, that means all these angles here have to be 90 degrees. So that's a good start there. Okay. The next thing I notice is I look at this diagonal, and I know this diagonal will cut angle A, so this big angle here, into two equals angles. So angle 60 and angle A here, this green angle, they have to be the same because this diagonal is bisecting. We're cutting into equal parts. So that I now know this angle here has to be 60 degrees. So now using a property of not a rhombus, but a parallelogram. Remember, rhombuses are parallelograms. We know that opposite angles, so this entire angle, which is 120, has to be equal to this angle, which should make it 120. But because of the diagonal, it splits it into two equal parts. So these two angles need to match these two angles based on our properties. So that means this has to be 60 and this has to be 60 as well. And what you should notice next is my eyes go to this shape here. It's a triangle. And in this triangle, I know two angles, and I can use triangle sum theorem to find the third. So I can do 60 plus 90 plus, we'll call this x, has to equal 180, and this is by triangle sum theorem. So now I'm going to do the math. 60 plus 90, that's 150 plus x, that's going to equal 180 here. Subtract 150. X is going to equal 30. So we now know that this angle here has to be 30. If this is 30, because this is a rhombus, we have this diagonal. This diagonal will bisect this entire corner here. So that means this bottom part has to match it. That's 30. And because this is a parallelogram as well, opposite angles need to be congruent. So these must be 30 and 30. And those are the properties we use to fill in the blanks. Let's go to our last quadrilateral. This is a square, and a square is basically a parallelogram with four congruent sides, so it's like a rhombus, and four right angles, so it's like a rectangle. So essentially, a square is a rhombus and a rectangle mixed together. Because of that, it's going to have all the properties of a rhombus, all the properties of a rectangle, all the properties of a parallelogram, and all the properties of the quadrilateral. A square has all properties of these shapes. So I'm going to list them. And these are just things we have to remember, but you should know these properties individually. When it comes to a square, it will include all these properties. So below is a list of quadrilateral properties and definitions, parallelogram properties and definitions, rectangle properties and definitions, rhombus properties and definitions. Again, all of these put together are the properties of a square. So by far, the square has the most properties.